Thank you. Can you hear me at the back, everybody, clearly? Cool. Yeah, so what we're going to do today is kind of a semi-hands-on workshop. So I have some aspects of the whole presentation which are more at a higher level, conceptual aspects of designing and mocking APIs. We won't really go in depth into development, or like, as in we won't really be touching code. The whole idea behind this workshop is to see how you can plan and execute on your API strategy while you are building your products. And for everyone here, if you want to follow along, I would recommend that you install the Postman app on your computers. So go to getpostman.com/downloads, and you can install it from there if you don't have it already. And I'm talking of the native app, so if you have the Chrome extension, that's not going to really work. And I would also need you to create an account and sign into Postman, because some of the features we'll use, like mocks and all, will need you to have an account. So you can just sign up for a free account and log in. That is if you don't have it already. What we will be focusing on, like I said, there is an aspect of the concepts around API development with some emphasis on collaboration, because as we understand it, Postman collaboration is the primary driving point when you're working with teams. So how do we actually collaborate? What are the kind of workflows? And what I would want to do is kind of take a workflowy approach and just show you where Postman might fit in, and not necessarily go in depth into specific features. We, of course, have our learning center and all the resources that you can also follow up. And the hands-on part of the workshop is where we would be kind of role-playing-ish, I would say, where we would look at the API design process from a producer's perspective or a publisher's perspective, and also from a consumer's perspective. So like I said, the workflows is what we will focus on. And this is probably going to take about 2.5 hours. So you've got me for 2.5 hours. So the other thing about questions, though, do we have mics to be handled out? We do. So if you have any questions in between, I would recommend that you take a note of them. We'll have 3 slots for question and answers. And those will be enough time to kind of catch up on the things that we will be talking of in between. So the concepts. Now, before I begin, I, as usual, start with a show of hands. Just wanted to have a quick look. How many of you actually have Postman installed right now on your computers? Who doesn't have? Oh, just cool. You have done half my work. The other part is, how many of you actually build APIs? So you're part of teams. How many of you are developers who build APIs? OK. And how many of you are managers who manage teams that build APIs? And how many of you are not in engineering but use APIs? Ooh, I see a few hands go up. Cool. So again, what we see a lot is that when we are talking about APIs, these are collaboration units within an organization. So if you think of APIs as products, they, at the fundamental level, are encapsulating some information that you would otherwise have presented to your consumers. And while doing that, we often come across some issues around, let's say, how does the architect team or the design team of the API actually collaborate with the team which is building the code, and how does that collaborate with the consumers who are supposed to use the API, whether it is for your internal purpose or for an external thing. And just to kind of make it very obvious, when I talk of APIs for this workshop, or when Postman talks of APIs, we mean web-based APIs over HTTP at this point. So we are not talking of system-level APIs, just to create that thing. And at the core of this, the reason why I would say Postman became that popular a tool is around the time when Postman started, in 2014-ish, is when you had this huge wave of not necessarily just microservices, but a more service-oriented distributed architectures coming in. And applications grow in complexity, you all are aware of that. And when we start having these multiple components which interact with each other, whether as part of a services system or whether you are working with your partner APIs, you end up with these systems which talk with each other. And that is what APIs fundamentally are. They are the boundaries or the bounded contexts, as you can say, of each domain. But what we are going to focus today is that we need a clear protocol or a clear agreement between these systems interacting with each other. So the whole concept of API first, which is where you are planning for the API, or rather, let's say you are designing the surface of your application before you actually start building it out. So what we would try to get to by the end of this workshop is give you a clear idea of how you would start designing your APIs before you implement them, so that by the time you're implementing it, you have a solid specification, you know how things are, there are no back and forth. So the whole consensus around what your API is supposed to provide is already there. We talk a lot about the API first design approach. And there is this publication that Postman has on Medium called Better Practices. And a lot of our content there is focused around how this API first workflows affect different parts of the industry. So at the core, when we are talking of API first, we have three main factors: that there are stakeholders who need to agree on some of the schematics or the way these systems are supposed to interact. For example, if I am the consumer of your API, I need to be aware of what are the authentication methods I need to use. I need to be aware of what are the endpoints I should use. But more than that, if you are the producer and I am the consumer, I would expect you to fulfill the requirements that I have. And this kind of sounds antithesis in a way, because typically what we see is it's the producer that decides what happens. And for example, if you are a consumer and you are consuming, let's say, the public Twitter API or the GitHub API, then GitHub has already built that, or Twitter has already built that for you. So you would be using that. You don't really have that much of a say in it. But when it comes to internal APIs, when you have got your engineering teams working on services, or you have got your partner APIs, so let's say you use a different provider for your billing, you use a different provider for your infrastructure. So all those things come together into an agreement, which, again, these are the best way to design APIs, you can say, is by splitting it into domains. And this is where the domain-driven design, the whole concept around domain-driven design comes into place. That's one of my favorite topics, but I don't want to go too much into that because that itself is probably a 3-hour workshop. But there is this seminal book called Domain-Driven Design by Eric Evans. That is the one I'm referring to. So at the core, it is agreeing on the domain boundaries, that these are the units of abstractions that I have and the data models. And if you look at it, the agreement part of it is essentially the collaboration between the stakeholders, that the producer and the consumer need to be on the same page about what is being designed. And the domain boundaries reflect the business use cases and the units of operation in the system itself. So how you split your APIs internally, how you build multiple services, what are your boundaries in there. They essentially are encapsulating a lot of business logic in them. Just like if you're used to object-oriented programming, the objects that you, or the classes that you create are encapsulating the business logic inside. So APIs are a high-level abstraction on that, and a way to design a good API is to make that encapsulation come really well. That is, you should not hand over the responsibilities of processing your APIs to your consumers, but you should give them an interface which makes sense to them from a business use case. So we'll go a bit detailed into that. But then the third part that comes in are the data models, where you need to have a clear idea of what are the resources that are part of your API. What are the data structures? What are the data models? How do they interact with each other? So when you have these three things and you start on it, you kind of get to this process that we call as API first development. And I might repeat this term again and again. In a way, this is not a new concept. Behavior-driven development is pretty close, I would say, to what API-driven API-first development is, where you identify the behaviors first, or test-driven development, where you write your tests first. And all of these have this common approach that you know what you are doing before you start to do it, and not that you start to code it and then you realize that, oh, I need to add this endpoint because I have some requirements. Now, what this gets to is that by the time you are in the design phase, if you do the data models and the business logic, the encapsulation part of it pretty clear, you have like a linear flow to the implementation process. So if, let's say, you follow a sprint cycle and you are designing an API or you are improving an existing API, your design process needs to kind of complete and have a solid specification around it, which then goes on to the implementation phase where it's developed and published. So we'll focus more on the design aspect today. The implementation is something that I'll leave it on to you to work. But the key problem that I've seen people face with an API-first method is that business requirements change. You might start with a certain set of requirements, and after a month, you might have an evolved set of requirements. So you also need to make sure that you have that flexibility in your design, which means if there is a change, that change should not break your existing consumers. If there is something new coming up, that should not impact what is already there. If there are performance concerns, you should be able to isolate that. You should be able to, just like you use version control to identify which part of your code shipped out, you probably want to apply the same to your APIs because, and this is what PostCon is about. We have a lot of people talking tomorrow around the different importances of all the stages of the API lifecycle. So probably come back tomorrow again for those parts. I'm just kind of covering this. So at a high level, if you work with APIs, this is one book I really, really, really recommend. And it's probably one of the most well-written things in this landscape. So continuous API management. One of the things that I learned personally from this book is what is an API. So when we say API, let's say, let's do another quick show of hands. How many of you think that the GitHub API that you see, would you call that as an API? So when you say API, what comes in your mind? Is it what GitHub has hosted? No? OK. Or when you say an API, do you feel like it's the server that's running, which is returning JSON response? Something like that? Yeah. How many of you are familiar with OpenAPI and schemas in general? So does that sound like API to you? So what happens is the term API kind of has multiple connotations, and we end up using it in different stages. So just for some disambiguation, there is something called the interface of an API, which is kind of the schema which determines how the API is supposed to behave, which documents and lists down the behavior of the API. So you would use OpenAPI. You can use Postman collections to do that. You can have a GraphQL schema. So this is the description part of the API, which is where you're defining the interface. So API, the I is interface, right? Then you have the implementation. And when we often say that we are building an API, we often mean that, OK, I have the repositories where my code lives. I have my databases, which have to be, or data stores, which have to be part of this. I might have built a service-oriented architecture to handle that. But then you also have the instance of it. And the three I's, essentially, interface, implementation, and instance, are often something that we collectively talk of as APIs. The instance, think of the instance as the actual hosted instance of your API. So the interface plus implementation. So you have designed your API, you have built it, you have created it, and then you host a public instance of it. Now, to give an actual example, let's take the GitHub API example once again. So the interface would be what GitHub maybe publishes as, let's say, the GraphQL spec of their API. The implementation would be how they actually build the internal workings of the implementation. And the instance would be api.github.com or github.com/API, that thing, where you have the interface plus instance, and you might have multiple instances. You might have a staging instance, a beta, you might have a production, you might have multiple versions of the instance, and so on. So these, like the interface and implementation combine into the instance. But today, what we'll be talking of, again, is the interface part of it. So we'll be focusing more on the interface. We won't go into the implementation, and the instances way beyond this scope. So coming back to a few key concepts. Now, here is some terminologies that I just want to get clear, because we'd be talking on these terms a lot. So when we talk of APIs, the roles primarily, we have the producer of the API, the people who are actually creating and are responsible, or the creators of it, and the consumers of the API who use it. Now, producer, provider, the terms that you might use in this case might vary, but often when we say producer or provider, we mean what I'm calling here as the producer. And what actually happens is the producer responds to the requirements that a consumer has. So if you know what your users need, whether it's, again, it's an internal API or it's an external API, you have to treat your consumers as a first-level citizen. Just because you're building an internal API does not mean that you treat them any less. So based on these requirements, the producer is the one who actually creates the resources for the consumers to consume. And then you kind of see the APIs being deployed across 3 scopes, depending on the business requirement. So private APIs are, again, think of them as internal APIs behind your firewall, behind VPCs, the systems that are actually running your whole software. The partner APIs would be if you are a company and you use Stripe for payments, so Stripe is your partner. So Stripe is providing an API for your partners, so limited set of access. And then you have a public API, where by public API, we mean that you would need maybe an access key, but it is open to a larger set of people. So just defining that, and how your API is, like in whichever of these stages, you kind of have more number of potential consumers. An internal API might just have a few downstream consumers, like other services which would be using it, or all the internals, essentially. Then you have the partner APIs, where you would have people sign up maybe, and you have a restricted access to it, but public would potentially have more consumers. And then schemas. When we say schemas, we mean the systems you use to describe the API. Like I said, in the interface. So schemas are what you often use to describe the interface. Now, the simplest possible schema is probably a wiki page, where you have the description of everything. And then you have the idea of structured schemas, which let you work with those things programmatically. So if you have a wiki page where, and also let's see a quick show of hands. How many of you actually have your API schemas in wiki pages or some documentation? Pretty few. It's amazing how many hands went up last year and how few are here, which means we are probably doing a good job at telling people that you need executable specifications. So the main thing is that when you have something programmable, when you have something that can be built upon, you can build other things from the schema. So one of the main purposes of having a schema is that you can generate a documentation out of that, and that documentation gets tied to your schema. I'll show how we do it in Postman as part of the workshop. But you can also do, if you're using OpenAPI, you can also generate stub codes from the schema. You can generate tests in case of Postman. So similar with GraphQL, RAML, you can use a JSON LD schema. There are a lot of items missing in this list. These are kind of the ones that we see interact most with the Postman ecosystem. And OpenAPI has got 2 major versions that are used currently, the 2.0 and the 3.0. So with these schemas in place, and then you know the roles, you know the scopes, and the type of schemas, you kind of make a choice that how do you go ahead and what kind of tooling do you choose? And the tool set that you choose would pretty much depend on these questions. So if you are the producer of an API or the provider, one of the first things you would want to understand is how would you gather your requirements? Like I said, the producer needs to get the requirements from the consumer. So that can be simply a meeting, that can be through some collaborative tools. You might have a doc somewhere, people commenting. But you need to get those requirements in one place in the first place. And then as you build out the schemas, as you build out the designs, you need to share those with your consumers. So how do you share those API documentation? How do you share the resources people need to get started to consume your APIs? Are something that you need to figure out. So again, the tool chain would depend on what your answers are and what environment people need to consume these in. And how do you collect feedback? And by feedback, I mean not necessarily asking people that, hey, did it work for you? But how do you build something in the system itself where you know that if, let's say, you as the producer, you have made a change to an existing endpoint, how confidently can you say that you have not broken anyone else's existing workflows? So how do you collect that feedback? That becomes a kind of a challenge in here. And then the flip side of it, as a consumer, how you give your inputs becomes pretty important, and often a result of API programs not working is this bridge not being there properly, where consumers are not able to tell the producers on time that, you know what, this is not working for me, or I'm seeing issues, or I want something more out of your system. Then the documentation that is available, how do they consume it? So just the other side of the questions. But the third point, and the most important, is how do we test our requirements? That is, I have given you a set of requirements. You have told me that you have done it, but how can I be sure of it from a consumer's perspective? So we'll look a bit into that part as well. Now, again, at a very high level, there are three things that you need to be very clear about when you are doing some sort of API design. First, the interface, then as in designing it, then the documentation, and the third is collaboration. So mostly we'll focus around these three themes today. So like as you can see here, building a testable and executable spec is one of the key things that we'll focus on. And when I say testable and executable spec, it is that you should be able to not just statically define what your API might look like, you also should be able to assert against that. You should be able to write your tests against that, execute them in a continuous flow as over time or as you have new changes. But most importantly, you need to know when things break. It's not just that you need to know when things work, because, well, things work most of the time, but when they break, how easily, how efficiently can you spot where exactly is the error? Because now you're dealing with multiple sets of teams. It's not just your code, it's someone else's code, which you don't know what's happening inside. So from your perspective, you need to be pretty clear about that. And then on the collaboration aspect, we'll talk a bit about mocking of APIs, and then around writing API contracts as a consumer. And yeah, in terms of tooling, I will mostly follow Postman, and for the schema, I'm going to use OpenAPI 3.0 in YAML format. So I have a hypothetical use case, which kind of builds towards this one question, that what is my single source of truth? That I want to have one source. If I have a schema, if I have an OpenAPI schema, that should be my source of truth for the documentation, for the tests, for how the interface that I see. I should not have to go and ask people that, hey, I've seen this API schema, but my API is returning some other kind of response. That's not really acceptable. Also, you should not have 4 or 5 different documentation. The documentation, if it is manually written based on some schema, then you have this issue where the docs might not stay updated if something changes in your schema. So having all of those, one of the cornerstone of effective collaboration in API design is having a single source of truth. So we'll see how we'd be getting to that. So setting things up, like I already said, if you don't have Postman already, go to getpostman.com, and just a bad pun there. So if you go there and install it, just make sure that you have logged in with an account. And what we want to get started without like telling you too much at a higher level, actually showing you things, is, well, I love cats. And I tried really, really hard to come up with a more serious use case around it, but could not. So essentially, we'll just look at a cat management API as both producer and consumer. If you don't like cats, make it dog, make it people, make it aliens, your choice. But we'll just look at a simple CRUD-based approach. So we'll just be like building a hypothetical API, which in the first iteration of it would have 2 endpoints. So we'll just plan for get/cats, which would be returning a list of all cats. So think of this as the use case that we are building today. And we'll actually build this in Postman with collections and everything. We'll not be coding, really. You can write tests. I'll show you some of the tests. But more of the testing thing is in the second workshop that we have today. So you can say that the second workshop kind of complements what we'll learn here. And I've kept it simple. So we'll just have 2 routes, the get/cats and post/cats. And both of them will deal with a schema of the entity cat with 4 properties, which is listed below: the ID, name, breed, and age. And this is typically how your business use cases would also be at a far more complex level. But let's say the cat schema is your data model. The one that we have on top, the routes, are the endpoints that you have decided to actually expose that model with. And we'll also look at evolution of an API and also look at how API design evolves as changes evolve. So we'll also look at a hypothetical scenario when a second version of the same API has to be shipped out, this time with another route which gives you a specific cat. Because in the previous one, we had the get/cats, which would have returned list of all cats. And we'll then add a specific one, which when given a cat ID, will return a specific one. But the schema that we'll use, or rather the data model that we'll use for cats, is still the cat schema that I told here, which means it might return an object. If it is a single entry, it might return an array of objects. And the syntax that we'd use for the API itself is based on JSON, but then you can implement this in GraphQL or any other format that you like. It might as well be CSV. So the data format is kind of not as big a requirement for us here, but just to keep things uniform, I'm going to use JSON. So yeah. I will also, just to, before I begin, just run you quickly through the set of features in Postman that we will cover as part of this, just so that everyone is at the same page. And can I have another show of hands? I know I like showing of hands. How many of you use Postman only as a REST client? OK, how many of you think Postman is more than a REST client? How many of you would love to know more about the more than the REST client part? OK, I see some hands down. That was interesting, though. I mean, just so you're clear, we are talking of Postman here and beyond the REST client. So, well, at the core of it, everything in Postman starts with a collection. And I feel like when I'm old and might have white hair and all, that would be something that people would quote, because I end up saying this thing exactly the same sentence in every presentation, that everything starts with a good collection. And so if you're just used to sending requests in Postman, you can group them together. Like if you're just used to the history thing on the left, you also have a second tab called collections, which is just like a group of requests that you can build together. And by requests, I mean the HTTP requests that you create in Postman. And you can actually save them into a collection. What I want to show you quickly is, so I mean, the one that you're seeing here is the Postman Canary version, which is something that you can also download and use. It's just the slightly more bleeding edge thing. So we have this thing called Bootcamp. If you look at the bottom part, and I would recommend not to start this right now, but after you go home, you can go through the bootcamp because it has some interesting lessons around the collections and automated testing, API docs and all. So it's a great place to start. But again, coming back to collections. So you group your requests into these collections. You can organize by folders, subfolders. You can have this whole representation. Collections have descriptions. You can write your documentation in that. I'll show you how to do that. And then one interesting thing about collections is you can also run them. And when you run a collection, Postman executes the requests that you have in the collection one by one. And you can also control the order in which the requests are executed, which means you can use collections as a way of building API-driven workflows. So if you are interacting with multiple APIs or if you're testing an API, you don't want to go and click the send button every single time, but build a collection, put your tests, put your documentation, and you'll be able to run that. We'll see some of that. And then Postman has this dynamic behavior through, as in Postman introduces this dynamic behavior through variables. And those variables are the double curly braces syntax that you use in Postman. And we have these multiple scopes of variables. I won't go too much in depth, but the most common ones that you see are the environment variables. So the environment that you have in Postman, top right corner thing, there are these scopes of how the variable is resolved. So if you have something declared in the global scope in Postman, that can be overridden by something which you declare as a collection variable. The same variable can be overridden by something which is environment, and then you can also have a local variable. And these can be manipulated through scripts in Postman as part of your requests. So you can take data from somewhere, store them in a variable, reuse them in the next request, and build really interesting chained workflows based on that. And the foundation of this, if you look at collections and variables, these two come together to build most of the automation. Like everything else builds from there. But then we also need a unit to see all of these together, and that is where workspaces come in. How many of you have used team workspaces in Postman? Okay, so in a way, you can think of workspaces as the container units for all the collections and environments, mocks, monitors, everything in one go. And workspaces are part of teams. So you have one team in Postman which can have multiple workspaces. You can also have personal workspaces. And anything that you create in those workspaces gets shared with anyone who's part of that workspace if you're signed in. And Postman syncs the data so you don't have to bother about actually exporting a collection and sending it to them. And then the scripting part that I was talking of, Postman ships with a Node.js-based scripting environment. And this is a request view in Postman. So you have the pre-request scripts, which are executed before every request is sent. And this is what you can use to populate a request. So Danny and Trent are going to go really deep into pre-request scripts and tests. So both of these are written in JavaScript. The difference is that, in short, tests are executed after a response is received, and pre-requests are executed before a request is sent. So you use that to then build a lot more things. But tests also have the option to create assertions on the response. So because you already have access to the response object by then, you can write things like you want to check what's the status code. You want to check how long did the response take. You want to check what's the response body, headers, everything. You want to send the response somewhere else. You can do all of that in tests. So we also have this snippets on the right-hand side. So if you don't want to write a lot or just want to quickly check how things work, you can use those snippets. I'm not going to go deep into this because essentially what you see on this screen is the next workshop. So that's 3 hours right there. And then we talk of the Postman API, and it kind of comes full circle because we are talking of building APIs with Postman, and we have a Postman API which you can debug in Postman. That's a lot of API and Postman together. And sorry, that was a really bad one. But you have api.getpostman.com. And the interesting thing is, whatever you are doing in the Postman app is available through the API. So you can build your own workflows. We have a command line collection runner called Newman, where you can also use the Postman API to fetch your collections and do some automations around it. So do check api.getpostman.com. We won't be using much of it today, but I just thought it's worth mentioning. Now, this is where we come to the interesting parts. This is, so far, whatever I have shown you are entities in Postman or products that Postman provides. But then we have this concept of blueprint collections, which are just collections, but the way you structure them. So we often create, and this is part of how you use, how you do API design in Postman, is that we often create these collections which act as references as well as representations of how an API is actually supposed to work. So think of blueprints as the producer of an API saying that this is how you're supposed to use my API. That my API has these many endpoints, each of them has this response body, it needs this request, it has this authorization. So all of that defined, and maybe along with tests, is what you kind of have in the blueprint collection. And the idea is the producer of the API gives this blueprint collection to the consumers, which they can then use to create. You can also publish any collection in Postman. If we have time at the end, I can show you that, or we can talk about that. Yes? Oh, they're just collections, so we just call them blueprints. Yeah, it's like lemonade, honestly. It's just a different flavor. So collections are, at the core, just a group of requests. And how you organize it, you can think of blueprints as a pattern of building collections, like a workflow of building collections. We just call those type of collections blueprints. So like I said, internal speak. Not something that Postman gives you, but I'll show you how you can build one. Or you can call them reference collections if you want. Then we have mock servers in Postman. And one of the key things, and this is something that gets a bit tricky to understand if you're new to API design, is if you are used to testing software in general, you would know the concept of mocks, where you just create a simulated entity and not the actual one, but which mocks the behavior of the actual entity that it is supposed to be. So you can do the same with APIs. That is, when you start, let's say, like I said, the cats, get/cats, if I don't write a server, if I don't actually code it and put it up, there is no way for my consumers to use my API and test it. So I can provide them with a mock, which just takes in a request structure and gives a predefined response, which you can then use for testing, you can use for development. So we'll cover a bit around how we can do mocks. And then the collaboration aspect of it, the agreement, the feedback loop can also be driven through comments. So if you have not noticed, the screenshot is not that visible. I'm not sure on those screens. But there is this small thing called comments just under the send button. So if you are signed in into a workspace, if you are signed in as part of a team, you can tag your team members. You can comment right in the app itself. You can tag them as well. What this does is keeps the conversations contextual. I mean, of course, we use Slack a lot ourselves. We have Confluence where we document things. But sometimes there are these contextual things which get lost. So you can actually have that discussion right in there. And if as part of the internal documentation, you would also see those things in place.